शाहजहां ने factorization, okay, because in order to find out the square roots and cube roots, you have to factorize first. Okay, another thing which is very important before I start this topic is that you should know your tables really well. Okay, if you have not learned your tables, then this will be hard for you to do. In fact, impossible for you to do. So that's the first step, to be able to remember the tables. Okay. Okay, first of all, what are prime numbers? Can anybody tell me what are prime numbers? Yes, Umar. Yeah, you can
Teacher,
unmute your. Yes.
prime numbers are the numbers which cannot be divisible by any number, which have only two factors, which is itself and zero and one. I mean by.
Yes. Yes. Okay. Zores, you wanna say, you wanna add something?
Oh, a prime number is a
Yes.
number in which it is it can be divided by only two possible integers, itself or by one.
Very good.
And more than two would be a composite number.
Okay. Yes. If it has more than two factors, then it's a composite number. Okay. Another thing. What about 0 and 1? Are they prime or composite? 0 and 1?
They 0 and 1 aren't prime nor composite.
Very good. They're neither prime nor composite. Very good. Yes. Okay. So prime number, then therefore the definition of prime number would be any number greater than 1 that has factors 1 and itself. Okay. So prime number, you can, this definition is available on Google. So prime number is any number that has, which is greater than 1 and has factors itself and 1. Okay. So what are factors now? Since I used the word factors, what are factors? Does anybody know? Somebody other than Umar and Zores? Does anybody know what factors are? Ayan, Ahmad, Khan, Mariam? Okay, Umar, tell me.
Factors are like the numbers which are factors are like numbers of.
Yes, yes, I think you know it. Yes. For example, if I
For
say,
example, 16 and 4 is its factor.
right. So what does it
If
mean?
that factors are the numbers which are used to
Okay,
we multiply the factors to get a number.
yes, okay, okay. Mariam? Yes, Mariam?
Factors are numbers that you multiply together to get a new number.
Right, very good. Yes, so factors are numbers that get multiplied, the product of which. So if, for example, I say 1 multiplied by 2 is 2. Okay, so that means these are the factors because they are getting multiplied to give us this product. Can you please spotlight my video? How do I spotlight my video? Okay, so factors are numbers that get multiplied to give you a product, right? So we can say that 1 and 2 are the factors of 2, right? Or for example, 4 multiplied by 4 is 16. So that means 4 is a factor of 16, okay? So on and so forth. So now you know, so you know the meaning of prime, you know the meaning of composite, and you know the meaning of factors. Now, when we say prime factors, what does that mean now? So now what does that mean? Prime factors. So you know the meaning of prime, you know the meaning of factors. Now, if I combine the two prime factors, what does that mean? Yes, Mariam. Yes, Umar.
Prime factors are the factors which are prime.
Okay, so you are using, remember, whenever you define, don't use the same words. Don't use the same.
Yeah, it's like the prime factors are numbers which
Are getting,
are only divisible by itself and one.
see, so you know the meaning of factors, right? So these are
Yeah.
numbers which get multiplied and they are only divisible by themselves or by one, right?
Yes.
So you combine the two definitions. So factors are the numbers that get multiplied, okay, to give you the original number, and they themselves are divisible only by one and by themselves, meaning that they don't have any other factor other than itself and one. So that's what we mean by prime factors. Now, in your book, they have asked you to factorize, right? They have asked you to factorize. For example, let's deal with this question. Let's take this question. Express 539 as a product of its prime factors, leaving your answer in index notation. First of all, what is index notation? Yes, Ayan Ahmed. What do you understand by index notation? What does that mean?
Miss, index notation helps us to get the answer.
Sorry?
Index notation helps us to get the answer.
Yeah, but what does it mean? Okay. Huawei? You know, I asked, I cannot unmute you. Your audio is not, you're not connected to the audio, and neither are you using the proper and proper name, and you are not connected through your audio, so I cannot unmute you. Okay, Umar, you want to tell me what does
Of
index?
index notation, like in the answer of numbers, that index notation is like 4 square multiplied by 3 to the power 4.
Yeah, so you will say, see, index is another term for power. So for example, this, oh, okay, 2 to the power 2. So this can be called exponent. This has different names to it: exponent, power, and we also call it index. So nothing difficult about it. These are just different names for power. We can call it exponent, we can call it index. So notation is the way of writing. So that means write your answer in the power form, like write,
Teacher,
yes, in this form. Okay, so you have to write your final answer in this form. That's what they're saying. So express 539 as a product of its prime factors, leaving your answer in index notation. Okay, before I move on to this, do you want me to tell you how to find out if a number is prime or composite? Do you want to do that, or you know that already? Okay,
teacher, you can do that.
okay, you need help with that?
Yeah.
Okay. Now, if you want to find out if a number is prime or composite, I got this few questions here. Let's find out if they are prime or composite. Now, we know the meaning of prime and composite. Prime means like numbers are not divisible by any other number, and composite means that they can be divided by other numbers. Now, in order to solve such problems, you have to know the divisibility rules. Okay, now let me ask you divisibility rules one by one. Do you guys know the divisibility rules? Okay, let's start with 2. What do we mean by divisibility rules? Meaning how to find out if a number is divisible by another number. Okay, so let's deal with 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's say 10. Okay, so if you know these, you're good. Okay, so how to find out one by one. Let's do this question one by one, and let's see if this number is divisible by 2 or divisible by 3 or 4, and so on and so forth. So let's do 2 first. first of all, I want you to tell me the divisibility rule for 2, and then you tell me if this number is divisible by 2 or not. Okay, Urwa. Yes?
Yes, teacher.
Okay. Yes?
7 is prime number.
So first of all, tell me the divisibility rule for 2. How do we find out if a number is divisible by 2?
That it comes in the table of
Okay.
2.
Yeah, so how do you
And
find that out? How do you find that out? If it is...
not an ender. इनके हाथ कितने काले हैं?
Fatma, please mute yourself. Yes. Okay. Urwa.
Yes.
Yeah. Okay. So how do we find out if it is coming in the table of 2 or not? This is a pretty big number. How do we find out?
We will see that it comes in a 7 comes in the table or not.
Yeah. So you are looking at the last digit, right?
Yes.
Right? Right. So you
Yes.
are, so the divisibility rule for 2 is, okay, Javeria, you want to say?
Okay, the divisibility rule for 2 is that any number that is even is divisible by 2.
Yeah, so when you have a, okay, so Sidra wants to add something. Yes, you are right, Javeria.
The divisibility rule for 2 is that if the last digit of that number is even, that means it can be divisible by 2.
Yes, so if the last digit is divisible by 2, that means the whole number is divisible by 2. Okay, so remember this. By the way, these divisibility rules are available on Google. Okay, if you want, I can forward in the group, but they are easily available. And I think your teacher has also, my daughter's teacher has forwarded in the group. And some of the students have also pasted these rules in their math copy, you know. Okay, so this last digit, you have to look for at the last digit. If the last digit is divisible by 2, that means it's even, because all the even numbers are divisible by 2. Then the whole number is divisible by 2. Okay, so we can see that the last digit is 7. 7 is not divisible by 2. That means this number is not divisible by 2. Okay, let's move on. 3. What is the divisibility rule for 3? Yes, Umar? Okay, Mariam, Wasim. Yes, unmute yourself.
Me, teacher?
If the sum of the digits is divisible by 3, then it's
Yes. Yes, sum of the digits. So let's do the sum of the digits. 6 plus 6 plus 7. Okay, you should also be good a little bit. You should be able to do some mental math. Okay, 6 plus 6 is 12. 12 plus 7 is
19.
19. So 19. Do you think 19 is divisible by 3?
No.
Yeah, 3 times 6 is 18. And then 3 times 7 is 21. So you don't get 19. So 19 is not divisible by 3. That means the whole number is not divisible by 3. Okay, now let's do 4. What's the divisibility rule for 4? Yes, Urwa? Yes? Do you know?
No.
Okay, Umar? Yes, Umar?
Divisibility rule of 4 is if then
Okay, divisibility rule for 4 is that the last 2 digits, right? The last 2 digits. Yes? Who is this? Yes?
That if it comes in if it comes in 2's table.
Yeah, 2's table, and then I think it's the last 2 digits. It's the last 2 digits, if I'm not mistaken.
Can I answer?
Yes, please, Maria.
It is when the last two digits are divisible by 4.
Yes, when the last two digits are divisible by 4. So let's see, 67. Let's do 67. Do you think they are divisible by 4? I don't think so. 4 ones are 4. 6 minus 4 is 2. And 4 6 is 24. Please mute yourself. Congratulations, Huawei, but you have to name yourself. Okay. So yes, we're getting a remainder. So that means this is not divisible by 4. Okay, let's move on. 5. What's the divisibility rule for 5? Yes, Javeria?
A number is divisible by 5 if the last digit of the number is either 5 or 0.
Right. So this number does not have 5 or 0. So that means it is not divisible by 5. Okay. Let's move on to 6. What is the divisibility rule for 6? Okay, Umme Urwa. Yes.
Yes. The divisibility rule for 6 is that if it comes in 3 and 2 tables.
Yeah, the number should be divisible by 2 and 3, right? The number should be divisible by 2 and 3. So was it divisible by 2 and 3 when we checked? No, right? They were not. We just checked and they were not divisible by 2 and 3. So that means not going to be divisible by 6 either. Okay, what is the divisibility rule for 7? Yes, Javeria?
The divisibility rule for 7 is that we have to double the last number and add it. And if the number is, and then we have to subtract it by the sum of the remaining numbers. And if
Yes.
the number that is the resulting number is divisible by 7, then
The whole number is, yeah, okay. So we will double the last digit. Okay, so let's do it. Doubling 7, we get 14, right? Now what is left behind? 66. So let's subtract 14 from 66. What do we get? 6 minus 4, 2. 6 minus 1, 5. Is 52 divisible by 7? 7 sevens are 49, and then 7 eights are 56.
no.
No, teacher, it's 56. If multiplied by 8 would be 56, so no.
Right, so this is not divisible by 7 either. 6, right, not 52. Yeah, we are getting 52. Okay, okay, now let's move on to 8. What's the divisibility rule of 8? For 8, if the last 3 digits are divisible by 8. Now this one has 3 digits. So will we just simply, yes, Mariam, Wasim, you want to say something?
I was just about to say that, like, if the last 3 digits were divisible by 8.
Yeah, so but it has 3 digits. So we'll have to divide maybe itself. Okay. So 8 8s are 64, and then 8 9s are 72. So 8 8s are 64. 6 minus 4 is 2, and then 7. 8 3s are 24. So no, I'm still getting a remainder. Okay, so that means this is not divisible by 8. Let's move on to 9. What's the divisibility rule for 9? Again, the divisibility rule for 9 is the same as that for 3. That is, again, you will add all the digits, and if the sum is divisible by 9, then the whole number will be divisible by 9. But again, the sum of the digits is 19, and 19 is not divisible by 9. So therefore, so 9 is not a factor. Let's move on to 10. That's easy. For any number to be divisible by 10, the last digit should be 0. But as we can see, the last digit is not a 0. That means this particular number here is a prime number. This is a prime number. Okay, so this is how you decide if a number is prime or composite. Okay, now again, here we will do the same thing. We will check with the help of divisibility rules whether this number is divisible by each one of the digits, okay? Do you want me to do each number one by one? Then I won't be able to do the square roots, but you got the point, right? Yes, Omar,
Yes.
you want to say
Yes.
something?
Yes, teacher. Teacher, when you said that this number 667 is a prime number, in my school when I learned, my sir said that you have to check all numbers till 19 if it is divisible.
Till 19. Yes, you are
Yes.
right. Oh, yes, yes, you are right. Yes, yes, you are right. You should check till 19. Well,
Yes.
I'm not sure if we can. So has he given you the divisibility rule till 19?
He did not give us, but he told us that if you multiply and divide by working again and again, then you can know it. For example, if you want to know if 667 is divisible by 14, we don't know what's the table of 14. What we have to do, we have to then multiply
Subtract.
14 multiply by 2, we have to do the working. 14 multiply by 3, we have to do the working. 14 multiply by 4, we have to do the working. And then
Yeah, or you can or you can can use the cancellation method. Yeah, you can do this. You can cancel this way, right?
what is the cancellation method?
Like this, like this. 4 ones are 4, 4 twos are 8. This is cancellation. So if they can be divided, this is another way of finding out. Okay, if this is divisible by 14, you will be able to cancel. Okay, and if you cannot
Okay.
cancel, yeah, if you cannot cancel this way, then most probably this number is not divisible by 14. So yeah, you have divisibility rules of 11 as well as 12 and 13. Okay, they are available on the net. Okay, you can go and check divisibility test for 11. For a 3-digit number, sum of the outside digits minus the middle digit must be 0 or 11. So you can, go on. Okay, yes, Ayan, you want to say something?
Miss, but it would be hard to do the table of 19, and there will be a lot of questions.
Yes, that's right. Yes, this is yeah. So this is a tedious this is a tedious work to do. Okay. Okay. So let's do the 677. Okay. Let's do
Teacher,
677. Yes.
can
Yes.
you forward the rules on me?
Yes. Sure. I will. I will. Okay. Let me find this out. Okay. Okay. You know what? 667 is not a prime number. I'm wrong. 667 is not a prime number, but 667 has 23 and 29 as their factors. Whoa, 23 and 29. And how will we get there? Okay, let me look into this. Okay, let me look into this. If there's any shortcut. Okay, so yes, Ayan, you want to say something?
Yes,
And
Miss.
yes,
Will there be a lot of questions in the exam for prime and composite?
yes, Vita, yes, it is included. Yes, it is included. Okay, let's do 677. Let's do 677. So till 10 is easy. Okay, and then we'll see. Okay, 677. Let's do this. Sidra, do you remember how we take out the prime factors? Oh. Okay. Okay, let's do this. 677. So you will use so it's not divisible by 2, right? Because the last digit is not divisible by 2. So 2 is not the factor. Yes. Yes, okay. Okay, for 3, you will have to add Okay, 7 plus 7 is 14. 14 plus 6 is 20. So 20 is not divisible by 3. So 3 is not a factor. Okay. 4. For 4, you will have to see if this is divisible by the last two digits are divisible by 4 or not. So this is 77. 77 is not divisible by 4. Remember, when the last digit is uneven, most of the times it is not divisible by 4. Okay, so 4 is not a factor. Then 5 also is not a factor because the last digit is not 0 or 5. Then 6. For 6, this has to be divisible by both 2 and 3. And we just saw that it is not divisible by 2 and 3. So 6 is also not a factor. Then 7. For 7, you will have to double this. Double the last digit. So doubling the last digit is 7. The double of that is 14. 14 minus 67 minus 14 is 7 minus 4 is 3. 6 minus 1 is 53. 53 is not divisible by 7, right? 7 8s are 56. So this is not divisible by 7. Then let's talk about 8. Divisibility rule for 8 was, what was the divisibility rule for 8 again?
If last 3 digits.
Oh yes, last 3 digits. So again, we will have to divide the whole thing. Okay, 8 8s are 64. 8, okay, 8 8s are 64. 7 minus 4 is 3. And then 8 4s are 32. So yeah, so this is 8 is also not a factor. For 9, the same divisibility rule as for 3. So the sum of digits was 20, right? 20 is not divisible by 9. So 9 is not a factor. 10 is not a factor because the last digit is not 0. And so you can go on, but none of these numbers are a factor. Okay. Does anybody know if 677 is a prime factor or not? You know, I need to find some, I'll find some shortcut for this. I'll try to find out and then I'll share with you guys. Okay. Yes, anybody
The
know?
prime number.
Prime number.
Okay. Yes, it is a prime number, but 667 wasn't, right?
Yes, teacher.
667 was a composite number. Yeah. Okay. Yeah, this is difficult. So I will see. Okay, I will try to find out a shortcut, and if I find something, I'll share with you guys. Okay. Now, but this is the basic method. You should know the main idea. Okay. Hopefully they won't give you too complicated numbers. Okay. Okay, then let's move on to prime factorization. Prime factorization is what we were doing here. Okay, I'm coming back to the same question. Express 539 as a product of its prime factors, leaving your answer in index notation. So basically, I have to express this 539 as a product of prime factors, meaning whatever numbers will come here should be prime factors, meaning they should not be divisible by any other number except for themselves and 1. Okay, how do I get that? Now, this is the method that I use. There are different methods out there, but this is the one that I find the easiest. I mean, it's totally up to you, whatever method works for you, but this is what I find the easiest. Okay. So I will use the divisibility rules, and I make this, okay, these 2 lines like that. And this is like sort of division. This is like sort of division. So I will start with the smallest possible number, smallest possible number. Now, smallest possible number is 2, but I know that the last digit is 9. It's not even, therefore the whole number will not be divisible by 2. And remember, in this sort of factorization, I will only use the number that completely divides this number, meaning no remainders. Okay. So, but the last digit is 9. Okay, now let's add the digits up to see if it is divisible by 3. 5 plus 3 is 8.
Teacher, it is not divisible by 3.
Not divisible by 3. Okay,
Yes,
9
teacher.
plus 9 is 18, so 17. Yeah, okay.
17.
Okay, then definitely it's not divisible by 4 because it's not divisible by
And it is not divisible by 5 either.
5 either. 6, what about 6?
No, because 3 and 2 in the table of 3 and 2 it does not go.
And it's composite.
Yeah, okay. So, okay. I got a really hard number here. Okay. So,
Miss,
yes?
Miss, can anyone solve 2 so they can later tell you the answer?
Yeah, please go ahead, solve it.
Okay, Miss.
I got this number. I got this question from your book. Okay, I got this question from your book. Okay, let me see. Okay, divisibility rules. I always forget. I'm really bad at divisibility, remembering the divisibility rules. What? Okay. 2 and 3 to 7. What about 7? 9, 9, 18. 53 minus 18 is 11, 12, 13, 5, 4 minus 1 is 3. 7 5s are 35. Yes, it is divisible by 7. Alhamdulillah. Okay. 7. Now I know that this is divisible by 7. So now I will see by what number is it getting divided. So 53. 7 8s are 56. So I'll move back. 56 is greater than 53. I'm taking these two digits together. Why? Because 5 is smaller than 7. So I cannot divide just 5. I will take the next digit. And it is allowed to take the first two digits together. Okay. So 5 8s are 56. 56 is greater than 53. So I'll move back. 7 7s are 49. So I will write 7 7s are 49. 53. So I will now subtract 49 from 53. 49, 50, 51, 52, 53. So I have 4. 4, yes. I will carry 4 here. This becomes 49.
77? Is it 77, Miss?
Yes, so 7 7s are 49. Yes, it's 77. Okay. Now, this is easy. Now it's easy. 7 11s are 77. 1s are 7, 7 1s are 7. Okay. Now we know that 11 is a prime number. So of course, this will be divided by itself. Okay. Yeah. So are these factors prime now? Yes.
Yes, teacher.
So the key is that you start from the smallest possible number, first of all. Secondly, make sure that these numbers that you get here are all prime. So I can say that 539 is equal to 7 multiplied by 7 multiplied by 11. Okay. Now the question asked me to write my answer, that I should leave my answer in index notation. So they want me to write this in the power form, the exponential form. This is also called exponential form. So 7. Now.
Cube?
Yeah. No.
The square.
Yes, the square. How? Because whenever we write a number without a power, it is understood that the power is 1. Now we have the same base. But we have
7 multiplied by 7.
Yes. So when the bases are same, we add the powers. So 1 plus 1.
2.
And 1 plus 1 is 2. So 7 square into 11. So this will be my answer. This is in the index notation form. Now I cannot do anything about this. Why? Because this is to the power 1 and the bases are different. I cannot combine them. Okay, so I will leave my answer as here. I will leave my answer here. So this is the answer. Okay. Okay. So let's see if we have any other question like that. What other questions did I get? Okay. Do you want to do more prime factorization?
Yes, teacher, it's fun.
Yes.
It's fun. Okay.
Yeah, for
now,
me.
Okay. Did your teacher teach you some other method a factorization, or was it the same? Because I don't want to confuse you.
Miss,
It
It
was
was the
the
same,
same.
teacher.
Miss, it
Was it?
was the same, but it wasn't 1 plus 1, which you wrote.
Oh, you know what? Don't get confused by that 1 plus 1. I was just trying to explain you why you square. Sorry, where did I? It's the same thing. I was just trying to explain you why you write square when you are multiplying, because the powers are getting added. That's all I'm trying to say. You don't have to do this. If you want to skip this step, skip it. This is not important. I just wrote this to explain you that why does this end up as 7 square? Because their powers get added up. Okay, that's why it becomes. Now if it was 7 multiplied by 7 multiplied by 7, another 7, then of course you will be adding 1 plus 1 plus 1, so you would have 7 cube. 7 to the power 3 is also called 7 cube. Okay, so nothing different about that. Okay, same thing. Okay, so if your teacher has taught you the same method, then I'm glad, then you won't be confused. But yes, there are other methods of doing this. You know, they also make tree. Some people also make tree. You know, like 539 would be 49 and 11, and then 49 would be 7 and 7. Okay, like this.
I learned in this way.
Yeah, and then they do this. Yeah, this is the tree method. So it is up to you, but I find this easier. I don't find this easier, so it's up to you. Okay, now let's use this prime factorization to find out square roots. Okay, so same method of prime factorization, but we will use it to find the square root. Now, come here, Sidra. What do you understand by square root? What does this sign mean? This means?
Divide.
No, beta, this doesn't mean divide.
Division by 2.
Square root, teacher. This is the symbol of square root.
Yeah, but what does it mean?
Uh, it means find the square root of.
We have to divide the number in 2 equal parts.
It means 1 over 2.
You need to
yes,
find two numbers to multiply to get 70,056.
See, yeah, so this square root basically means to the power half, to the power of 1 over 2. It means to the power of 1. You can write it this way as well. Okay, you can write this way as well. Same thing. Okay, so yes, Javeria, you are right. Dividing this into 2 equal factors, 2 equal factors that will get multiplied by each other to give you this number. So, okay, so now let's find this out. So this is calculated by factorization. Okay, because why? Because we want to find 2 factors that will be identical and will get multiplied to give us this. So let's do this now. 7056. Now using the divisibility rule, we know the last digit is divisible by 2. So 2 is the smallest number. So let's start dividing by 2 and let's see if this works out. So 2 3s are 6. 7 minus 6 is 1. I will carry 1 here. And now I don't need to take the 2 digits together. Why? Because 7 is bigger than 2. So I can easily divide it. Okay, so I will take 1 digit 1 by 1. Each digit 1 by 1. So 2 3s are 6. I'll carry
10.
Sorry?
2 5s are 10.
Yes, 2 5s are 10. And then 2 2s are 4. 5 minus 4 is 1. I will carry 1 here. This becomes 16. 2 8s are 16. 2 times 8 is 16. Okay. Now, again, the last digit is divisible by 2. Again, the last digit is even. So I will continue my division by 2. Okay. 2, 1. 2 times 1 is 2. And 3 minus 2 is 1. I will carry here. This becomes 15. 2 7s are 14. 15 minus 14 is 1. I will carry here. And so this becomes 2 6 are 12. And this is 2 4s are 8. Again, the last digit is even. Again, I will divide by 2. So why? I have to make sure that these factors are prime and they are small as is possible. Now 1 is too small to be divided by 2. So I will take the first 2 digits now together. Okay, and make it 17. So 2 8s are 16. 17 minus 16 is 1. Again, this becomes 16. 2 8s are 16. 2 2s are 4. Again, the last digit is divisible by 2. I will continue dividing by 2. 4s are 8, 2 4s are 8, 2 1s are 2. Now here I'm getting a prime number as my last digit. So now let's use the divisibility rule. 4 plus, so I'm now checking the divisibility rule of 3. I will add the digits. 4 plus 4 is 8 plus 1, 9. So 9 is divisible by 3. So this number must be divisible by 3. So let's try 3 out. 3 ones are 3. I will carry 1 here. This becomes 14. 3 fours are 12. Okay, 3 fours are 12. 14 minus 12 is 2. 3 sevens are 21. This becomes 21. Now again this. Let me add them up again. 8 plus 4, 12. So 12 is divisible by 3. So again, 3. 3 fours are 12. Again, I'm taking these two digits together. 3 fours are 12. 14 minus 12 is 2. This becomes 27. 3 nines are 27. Okay. And this I know, 49 is 7 sevens are 49. And then 7 ones are 7. Okay. Now, in square roots, usually you will get these prime factors which you can divide into couples, couples. There's coupling going on in here, okay? But let me write it down here. Okay, let me write it down like
Pairs.
Please keep yourself muted, please. Into 3 into 3 into 7 into 7, okay, is equal to, okay, let me write it this way, 7056 to the power of half. To the power of half. Okay, can I write the same thing this way?
Yes, teacher.
Yes.
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 Yes. Okay. Now, if I want to get rid of these powers, okay, can I write them this way?
Yes.
Right.
Yes.
Okay, now if I want to get rid of this square, I have to multiply this by half. Or you can say I can multiply this by half. So 2 and 2 get cancelled. But whatever I do on this side of the equation, I have to do on that side of the equation so that this equal to sign stays true. So what did I do? No. I got this wrong. Sidra, how did you do this? How did you used to do it? So
we write these two numbers as one.
Yes. Mariam, you want to say something? Or Ayan?
Under the 2 we put a 1, so under the 2 power we put a 1.
2 2s are 4, 4 3s are 12.
No, but I want to get rid of this. How do I get rid of this? Remember, we used to cancel. Yeah, this is the answer. I know the answer, but I want to show them that step, in which we get rid of the.
You cannot get rid of this because this is what you want to find out.
Okay. Okay, so 2 2s are 4, 4 3s are 12, and 12 7 is.
See, you cannot get rid of this.
7 2s are 14, 7 1s are 7 8. So the answer, the square root of 7056 is 84. Yeah. Okay. But what I was trying to show you was 2 square, and then we multiply that by half, and so
Teacher.
Yes.
Teacher. In my school, I learned how to cancel these exponents.
Okay, please tell us. Share.
Yeah, teacher. After we did this step, after we made them into couples,
Yes.
we write this in bracket as you did, okay?
Okay.
And then you wrote the exponent. Then we have to, when we do this in this, then what will happen? We will cancel my sir said that then what you will do, you will cancel the exponent and the bracket. After that, you will multiply 2 multiplied by 2 multiplied by 3 multiplied by 7, and then you will get the answer. This is how I learned.
Yeah, I know this. I'm just forgetting it right now. It just
Miss,
slipped my mind.
Miss, may I tell?
Yes, please tell.
Miss, we have to first write, like, this is 756, so we have to write 2 multiplied by 2, but we don't have to write it in brackets. We didn't learn in brackets, Miss.
Okay, okay.
We wrote, yes, we wrote 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 7 multiplied by 7. Then down we wrote 2, and the on top of it we wrote 2, and on 3 we did the same thing. On 3 we have to also write 2, and 7 too. We have to write 2 there too. Then we have to write it in square root, the 756, and then
Oh,
we
you
have to
know
write.
what? You know what? I got it. I got it. No, 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 no. I got it. I got it. You know what?
Miss, in
See,
square root, then we cut with the
you know what?
2
You know
of them.
what? You know what? All these numbers will equal to 7056, not its a square root. All these numbers, when they get multiplied, they will give us 7056, not its a square root. So so 7056 is equal to this. So, but if I want to get rid of this, I will multiply this by half. Okay. And I will also, but this has no power, that means it has 1. Okay. This will also get multiplied by half. So 2 and 2 get cancelled, and to the power half means a square root. And so now I have cancelled the power out, and so now I can just simply multiply them. 4 2 2s are 4, 3s are 12, 7s are 84. Yes. So my mistake was that I was putting the square root here. All these factors, when they get multiplied, when you multiply these factors, they don't give us the square root of 7056, they give us the number 7056. Okay, so that was my mistake. Okay, it has been a long time since I am in touch with math, so yeah, please excuse me. Okay, now let's do this last question. Given that the prime factorization of 9801 is this, so they have already done the factorization for you, and they have also written the factors in the index notation form here. Find the square root of 9801 without using a calculator. So let me just use a fresh piece of paper for this. Okay, so they have already done the factorization for us. Okay, the factors are 3 to the power 4 into 11 square. Okay, now we have to find the square root. Again, to find out the square root, what do we have to do? We should have this in square form, because we are trying to find to the power half, right? So we want this to be, if I write it this way, 3 square into 3 square into 11 square. Can I write it this way? Yes, this is 4, right? So 2 plus 2 is 4. I have split this into this. Okay, this is same thing. If you write them in a singular, I mean in the single notation form, you will get 3 to the power 4. So I can write it this way. Okay, so again, if this is the same thing, right?
Miss,
9801, right? Yeah, just excuse me, and then I will let you speak. And so if I multiply this by half, so I will get rid of this square, but then I will also have to multiply this power by half, and power here is 1. Okay, so this will get cancelled, and I can write to the power of half as the square root of 9801. And so now 3 3s are 9, 9 11s are 99. So the square root of 9801 is 99. Yes, Ayan, was that you? Or Umar, was that you?
Miss, it was me.
Okay. Yes.
Miss, the answer is correct, but But our teacher told us a different way to do it.
Okay, please share with us.
Miss, do I send you in WhatsApp?
No, just tell me right now. Orally, tell me.
Miss, but I don't have the same question.
Okay, you can then send on in the group. Okay, so the question was asking this: given that the prime factorization of 9801 is this, find the square root of this without using a calculator. Now you can use different methods, okay, but of course whatever works for you, whatever you find convenient and easy, you should go with that. Okay, so what I have done nothing special here. I have just split this to the power 4 into square and square. Why I wanted square? Because I wanted to cancel to by when I multiply this by half, because I know that the square root is to the power half. So if I can get rid of this square, I can just simply multiply these numbers to get the square root. So this is what I did. I split this into squares. I got all the numbers under bracket. I squared all the numbers together. I canceled that power by multiplying it by half. And please mute yourself. And I also multiplied the power of this number by half. And so that was the square root. Okay, so this is what I did. Okay, now let's move on to cube roots. How can we use prime factorization to find the cube root? Again, the method would be the same, but this time instead of getting couples, we will get triplets. Okay, by prime factorization. So let me do just one question with you at least. 1728. Again, we will use the divisibility rule. The last digit is divisible by 2. So the whole number must be divisible by 2. So 2 8s are 16. I will take the first two digits together. This is 2 6 are 12, 2 4s are 8. Again, the last digit is divisible by 2. 2 4s are 8, 2 3s are 6, 2 2s are 4. Okay, again, 2 2s are 4, 2 1s are 2, 6 are 12. Okay, and then 2 1s are 2. Now, remember, whenever you take two digits together, which are not the first two digits, now I'm taking these two digits together, but they are not the first two digits. I will have to add a 0 before I take them together. Before I divide these two digits together, I will have to add a 0. Remember this. You can take the first two digits together without adding any 0. That's okay. But if you're taking two digits together, which are not the first two digits, then you will have to add a 0 before you divide the two digits together. Okay? Now, 2, I will take the first two digits together. 2 5s are 10, 2 4s are 8. Again, 2 2s are 4, 2 7s are 14. Now, this is no longer divisible by 2, but I know it's divisible by 3. 9s are 27. 3 3s are 9. 3 1s are 3. Okay? So now, do I have triplets? Yes, I have the triplets. Alhamdulillah. Okay. Now I will write 1728. I will not write cube root. I will not make that mistake again. Okay, so 2 multiplied by 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 3 multiplied by 3 multiplied by 3. So I will write it this way. 2 cube multiplied by 2 cube multiplied by 3 cube, 1728. I can also write it this way. Okay, now if I want to get rid of this, what will I do? I will multiply this power by 1 over 3 this time. Again, I will multiply this also by 1 over 3. Okay, this 3 and this 3 get cancelled. This can be written as this. Can you see? This can be written as 2 2s are 4, 3s are 12. So the cube root of 1728 is 12. Okay, is there any question?
No, teacher.
Okay, is this the same method as taught by your teachers?
Yes.
Yes.
Yes? Okay. Now, some students were having a lot of problem with this and they requested me. I think the problem lies in students not knowing the tables. That's another problem. So please brush up on your tables. Okay? And I will try.
Yes, ma'am.
Yes, and I will try to find out the shortcut for finding out if a number is prime or composite. Okay? And I will let you know if I find something. Or if you know anything, please let me know. Okay?
Yes, ma'am.
Okay, is there any question that you cannot solve and you want help with in the book or anywhere? Is there any question?
Miss, I sent you in WhatsApp the way we did.
Okay, and also if there's any question that you cannot solve regarding this prime factorization and finding square root and cube root, please tell me. Okay, let me know. Okay,
I have a question.
Yes, please.
On your last question of cube root,
Yes.
over there it was written 3 to the power 9, but we only kept it into two pairs.
Where?
On our last question.
This question?
Of square root.
Square root.
Yeah, that one.
This
no,
one? This?
The paper that's under the sketchbook.
Okay, this?
Yeah, it's written 9 over there, but we only kept it into two groups.
What do you mean? What do you mean? I didn't understand.
In the starting of the question, it's saying 3 to the power 9
No,
times
no.
11.
This is 3. No. This is 3 to the power 4. This is not 9. This is 3 to the power 4. Please excuse my writing. 3 to the power 4.
Oh, okay. Thank you, teacher.
Yes. 2 plus 2 is 4. Okay. What? Okay. Does anybody really quick? We have like 2 to 3 minutes. Can anybody do this real quick? 3375. Does anybody want to do this with me? Yes,
Yes,
Mariam.
miss, I can.
Okay, let's give Mariam a chance. Yes, Mariam.
Okay. So
Yes, it is composite.
it's 3 plus 3, and that's 6. And that's 13 plus if you add 7.
So, okay, so you are dividing this by which number?
5.
Okay.
Okay. And 3. Okay. And 3. And sorry, 5 6 are 30.
Very good.
And 3 is carry.
Okay.
Okay. 5 7s are 35.
Yes.
And now 2 is carry.
Okay.
5 5s are 25.
Okay.
Again, it can be by 5.
Okay.
5 1s are 5 with 1 carry.
Okay.
And 5 3s are 15.
Okay.
With 2 as a carry.
Okay.
And 5 5s are 25.
Okay.
Then again, it's divisible by 5. 5 2s are 10.
Yes.
And 3 is a carry. And 3 is a carry. 5 7s are 35.
Yes.
And over here now, 5 5s are 25. It's again divisible by 5. 5 5s are 25.
No, beta, this is 27 now.
Also.
Yeah, this is 27. So which number will you divide 27?
Teacher, by 3 we'll do it. By 3.
Yes, okay. So Arham, you tell me now.
Teacher, then we'll do it 37 by 9.
Very good. 3 9s are 27.
Then 3 3s are 9.
Very good.
3 1s are 3.
3 1s are 3. Okay. So now tell me. Yes. Come on.
5 multiplied by
So
3.
3375 is equal to 5 multiplied by 5 multiplied by 5 multiplied by 3 multiplied by 3 multiplied by 3. Okay. So I can write it as?
Triplets.
Yes, 5 cube into 3
In
cube.
the index notation.
Yes. And then 5 into 3 to the power 3, 3375 multiplied by 1 over
Cancel
3.
that out.
Okay. 3 get cancelled. So 3 can you see? Okay. 3375 and 5 3s are 15. Okay. Okay. You know what? I will also find out a shortcut for square roots and cube roots for big numbers. Okay, big numbers. We'll do big numbers. Okay, and then you know what? You can even search it yourself on YouTube. On YouTube, write down how to find a square root for big numbers, and you will find such interesting videos. They give you really nice short tips and tricks. Okay, and they're very useful. Okay. Okay, Sidra wants to share something. You want to share? Okay.
So like
yeah, okay, go ahead.
There's a really big number, like we were having a problem in 677. So to find out whether it's prime or composite.
Okay, can you hear Sidra? Okay, please speak loudly.
So first you need to see a square number.
Yes.
A square of a number which is like a bit above 677. So 28 square is above 677.
Yeah, we don't know. I don't know.
28 square is
28 square is, so you have to know the squares for that.
684.
684, okay.
So it's more. So now you need to know all the prime numbers below 28. So they're like 2, 3, 5, 7, 9, 11.
Okay, so maybe we'll do this in the next class because we are running out of time, I think. Okay. Okay, so you guys also go ahead and find out if there's any shortcut to find if a number is prime or composite. Okay, this is how we learn.
So you can see that it is
okay. Okay, then assalamu alaikum wa rahmatullahi wa barakatuh.
Okay, Allah Hafiz.
Allah Hafiz, Allah Hafiz.
Allah Hafiz, teacher.
Allah Hafiz.